Hello, can you all hear me?
Yes,
Yeah. Is the screen visible?
yes,
Okay. So today we'll continue with the rest of the portions of module. So we'll start with test types. So yesterday we have discussed different levels of testing, that is different test levels. And today now we are discussing different test types. So if you go look into the Google and search different types of testing, there are a lot of hundreds of different types of testing. So for ISTQB, they have picked four different prominent type of test types. So they are like the functional testing, non-functional testing, black box testing, and white box testing. So what is functional testing? We might have all done some kind of functional testing. So what do you mean by functional testing? What is functional testing? So most of the terms we can understand from the that particular term itself. What does that actually mean? So for functional testing, also from the term itself, we know it is checking the functionality of that system. So in functional testing, we are testing the functionality of the system. So here the keyword is what. So whenever you hear the functional testing, the key word should be it tests what the system is supposed to do, what the system is expected to do. That is what we are checking. The functions, what the system is supposed to do. So if we will be checking if the functionality or the requirement is complete, or if it is correct, or if there is any differences, all these functional based checks would be conducted for a functional testing. So this functional testing could be done for all the different test levels. So we have learned few different test levels. We have learned unit testing or component testing, the component integration testing, system integration testing, and acceptance testing. So these are the different levels of testing. And for each level of testing, the functional testing could be done. So when you are doing a functional check on component level testing, we are checking the functionality of that particular piece of code. So when you are doing a functional check on the component integration testing, we are checking the functionality of that integration between these two different components. So the component testing, functional testing could be performed at all the different levels of testing. So functional testing is nothing but the functions. We are checking the functions to be performed by the system. And the key word you should remember is what the system is supposed to do. Next is non-functional testing. So here the keyword is how well the system behaves. So there are so many different non-functional testing characteristics for a software or system. So like performance, compatibility, usability, reliability. So what do you mean by performance testing? So anything. So if you take the example of an e-commerce application, if you click on an add to cart button, or if you click on a login button and you realize that the product gets added to the cart, or you are logged into your particular website. So from a functional side, if the product is getting added to the cart, that means the functionality check is done, right? Whatever we expect from that particular user story, that is being done. So the functional test is done. Whereas when you click on the same add to cart button and the it is taking some time to for the product to get added to the cart, there is a delay. So how well the system behaves. So for the same scenario, there would be a functional side as well as a non-functional side. So when you are checking the non-functional characteristics of a system, that is called the non-functional testing. So one of the typical examples is the performance testing. So as a user, what we are expecting, as soon as we click on the add to cart button, the product should get added to the cart. There should not be any delay. So there it will be should be a well performed system or application. So whenever we give out a request, how fast we are getting the response, or how fast the system is responding. So if the system is responding faster, or is it taking a lot of time? So that is a whole performance, how the load testing is. So for every system, it will be designed for a particular load. For example, if a system is designed for 10 users or 100 users, so we will be doing a test to see how the system is performing for that designed number of users, for the say 100. So how the system is performing if the 100 users are using at the same time. And then you stress the system. So then you increase the system with a number which is more than the design number, that is more than 100. And then you check how the system is responding. So that is stress testing. So all these are um, non-functional testing characteristics. So the functionality side might be working fine, but again, we will have to make sure that the non-functional quality characteristics are also working fine or not. So performance is one important non-functional testing. Then there is compatibility. If it is compatible on different platforms or different languages or like that, if it is the usability is good, if it is user friendly. So all these are different non-functional testing characteristics. So it is equally important that we check the non-functional testing characteristics of a system or software under test. So that is a non-functional testing. Next is black box testing. So there is white box testing as well as black box testing. So what is black box testing? So when you look into a system, look into a black box, you can't actually see what is happening inside. So you can only see what you give and what you get back. What actually happens inside is not visible. So say that is similar to the black box testing. So whatever specifications we are given, we give an input and see what if the expected output we are getting or not. So that is a specification based testing, and it derives its documentation external to the test object. So we give an input based on the specifications given, and we expect for an output that is specified in the specification document. So that is black box testing. And whereas white box testing is something opposite to that. So if you look into the white box, you can actually see what is happening inside. So you are testing the internal structure. You should be knowing the logic or code or the program underlying structure. So the white box is where you check the structure based and derives test from the system's implementation or internal structure. That could be code or architecture or workflows or data flows. So it is very necessary that we should be having an understanding of the underlying structures of the system. So this would be mostly done by the developers who would be coding the system. That is white box testing. So these are the different types of testing. So functional testing, non-functional testing, white box testing, and black box testing. So now we have the next topic, that is a confirmation testing. So for any application, there could be two kind of changes that could happen in that application. So what are those two kind of changes? There are two type of code changes. There are two type of code changes that can happen in any application. What are those two kind of code changes? Whenever the code change happen in an application, two scenarios. What are the two scenarios where a code change happens in an application? എപ്പോഴൊക്കെയാ കോഡ് ചേഞ്ച് ഉണ്ടാവുന്നത്? കുറച്ച് ഉറക്കെ പറയോ, കേട്ടില്ല. ബഗ് ഫിക്സ് ആവും. One thing is when bug got fixed. So there is a code change that is being pushed. So bug fix is one scenario where a code change will happen. Another one is
update, new feature,
new
software
feature or update. Yeah, exactly. So there are two scenarios where code change will happen. So as a QA, whenever there is a code change, we are supposed to make sure that this particular code change is not creating any issues, right? So there are two scenarios. One is a bug fix. So whenever there is a bug fix, we as a QA do a test. Sometimes we might have to do retest for all the bugs related, all the test cases related to that particular bug, or we'll just have to retest that particular bug alone. So whenever there is a bug and we do a retest to confirm that that particular issue is not there, that is called confirmation testing. So we are doing a test to confirm that that issue is not there anymore. That is confirmation testing. So what is another name we commonly use for this confirmation testing?
retesting.
Retesting. Commonly we call it as a retesting. So whenever there is a bug, we do a retest to make sure that that bug is not there anymore. That is called retesting or confirmation testing. So that was the first change. And the next one is regression testing. So whenever there is a new feature added, we do a test to make sure that this particular new feature or new update is not affecting any of the other working functionalities in that particular module, right? So that is regression testing. So whenever there is a new feature added, we have to make sure that this is not creating any adverse consequences. And so we will have to run the priority test cases or the regression test suite to make sure that this is not creating an issue. That is a regression testing. So we can always say that regression testing is a strong candidate for automation. Why is it so? Because every in each sprint or after each sprint, we are adding the number of features. And we'll be adding more and more features. So, is it possible that by the end of fifth sprint, we may have a lot of test cases, maybe 100 plus test cases? It is not possible that every time when a new feature is being added, we can go and manually test all these 100 test cases, right? So we always keep a test suite, automated test suite with the priority test cases from all the previous features. So it could be run automatically whenever there is a new feature being added. So that is why we call regression testing as a strong candidate for automation testing. So there are two types of changes that can happen. That one is a confirmation sorry, whenever there is a bug fix, that is a change, then we do a test to make sure that this bug fix is not the bug is not there anymore. That is a confirmation testing. We are confirming that issue is not there anymore. That is a confirmation testing. Whereas when a new feature is added, also there we will have to do a number of tests to make sure that this particular feature is not creating any issues for the already working functionalities. That is a regression testing. So there is confirmation testing as well as the regression testing. And next is maintenance testing. So what is maintenance testing? Has anyone been part of a maintenance testing team? So what is maintenance testing?
After the product release, we will do the maintenance testing.
Yeah. So the maintenance
If I
testing period. Yeah. So it is like once the system is deployed in production environment, it would often be in service for years or decades, like whatever the contract is. Based on it, it would be often in service for years. So it is not like once we develop and install the software, it will just keep on running on its own forever and ever. So we might have to do a service which is agreed by both the parties. So any product, not just for the software, any product that we take from the market, whether electronics or any other, needs maintenance, right? So during this agreed service period, the software might be corrupted, or software there would be defects found, or it would be changed, or if it could be like updated with new features. So all these are changes. So as QA, our intention is whenever there is a change, whenever there is a code change, we have to make sure that it is not affecting the functionality of product, right? So during the service period, if the software is corrected for defects or changed or extended to support new features, we do a testing that is called the maintenance testing. So during the maintenance period, when we do a testing to make sure that for the changes it is not getting affected, that is a maintenance testing. So maintenance is needed to preserve or improve the quality characteristics of the different components or systems. So over the lifetime, as it goes on working for any product, it happens. So there will be wear and tear, and it would need some maintenance. It could be from a software perspective, it could be some corrective, adaptive, or any kind of changes that happen in the environment. Then we will have to do a testing. So we know one thing, like the one which I asked you earlier, have anyone been part of a maintenance testing team? No one. So one thing we know that before the maintenance, before the deployment, there would be 7 to 8 QAs. But in the maintenance testing period, there would be only 1 or 2 QA, mostly one QA only. Why? Because the changes or the corrections or the upgrades, we are not expecting those to happen very regularly or very frequently, right? So during the maintenance period, our expectation is not to have so many changes. So there will be only a few number of QAs allocated, right? So that is the expectation. But what if the maintenance is happening very frequently? Is it possible that we have 500, 600 test cases already, and during the maintenance period for every change we will have to run these 500 test cases again and again. That is not possible, because for from our expectation, the changes would be very minimal during the maintenance testing period. So in such cases, if the changes are very frequent, we will do a study. We will do a study on that particular change to see if we actually should go about doing that particular change or not. Because if the change is too complex, or if the change is too risky, so we might not go with the change, right? Or how the change is affecting the total functionality of the application. If it is too risky, what would be the consequences? What are the modules that should be tested? That is very important. So it is not possible that every time there is a change, we can go and run all the 500 test cases manually, or with a regression suite. That is not possible. Um, so what we do a study to understand the change, to help decide if the change should be made and what should be the potential consequences in other areas of the system. That study, we call it as a impact analysis. So impact analysis is a study to understand all these areas regarding this particular change. So if we have a proper impact analysis done, we don't have to actually run all the 500 test cases for every change. So if there are 5 modules and there is a change in module A, and this particular change in module A is only affecting module B, we might have to run only the test cases related to module A and module B. So impact analysis helps us to reduce the testing process during maintenance testing phase. So it also helps us in evaluating the success of the implementation of that particular change, and the regression that could actually be possible as if we implement this particular change. All these could be understood from the impact analysis or the study that we conduct on that particular change. So that is maintenance testing. So we have like mentioned a few triggers for maintenance testing. Like it could be corrective, when you do some corrective actions, or when you add new features, right? So there are many triggers for maintenance testing. Let's see what are the different triggers for maintenance testing. So there could be few triggers. One is a modification. So if there is a planned enhancement. So when you say planned enhancement, so you were um, before releasing the product itself, you had a plan to add a particular feature, but you thought like, we are not doing it right now. We will just park it for now, and we will add it as an enhancement later on. So we'll just release the product, and we will add it as an enhancement later on. So if you are doing such a planned enhancement, or corrective and emergency changes, if you find some issues or edge issues which were not found earlier, or if there is any changes for the operational environment, if a operational environment is upgraded, or if we move to cloud, or whatever modification happens, it calls for a maintenance testing. So there is a change, there should be a maintenance testing done. So that is modification. The first one is modification. Next is migration. So again, there is a change happening. So it is being moved from one platform to another. So there is a new technology or new method. So we might upgrade from one platform to another. So then again, we will have to do a proper maintenance testing. And finally, retirement. So for example, if for example, a banking applications which has been running for 10 years now, and they want to shut down the whole system and come up with a new solution. So there could be such things also happen. So there is a retirement of application. Again, this could not be affecting the customers, right? So that will also call for a maintenance. So these are the different triggers for maintenance. It could be modification, or any migration happening, or the case of a retirement as well. So these are the different triggers for maintenance. And the scope of maintenance testing, how well you will have to do the maintenance testing, it will depend upon few factors. So one is the size of the existing system and the size of the change. So what is the size of the existing system? What is the size of the change? And the one very important factor is the degree of risk of the change. So how this particular change is going to affect the applications, if there is any critical risk. So for example, there was an Android update which happened few years ago. So after the update, the whichever phones was upgraded to that particular version got crashed, right? So that is because proper study was not done for that particular change. So degree of risk of change, and the size of the existing system and size of the change are few factors which affect how well, what should be the scope of maintenance testing that is to be done. So yeah, so this is the last topic in this module, that is a maintenance testing. So we have covered today different test types, that is in functional testing, non-functional testing, black box testing and white box testing, and then um, confirmation testing and regression testing. Based on the changes, we will have to do either confirmation testing or regression testing. And finally, during the service period, we will have to do a maintenance testing for any change that happened during the service period. So with that, we have come to end of module 2. So there will be 6 questions from this particular module, module 2. And yeah, so next module is module 6. So if you look into the module 6, are there any doubts regarding module 2 before we actually move into module 6? Any doubts? Okay. So we'll move to module. Okay. So we'll move to module 6. So one very important thing about this module 6 is that if you look into the syllabus, you can see that there is only 1.5 page for this module 6. Module 6 is only 1.5 pages of content in your syllabus, and you have 4 questions from it. So that is actually good because you don't have to read and understand a lot, but with 1.5 pages of content, you can actually score 4 questions. Whereas the module 2, it's a little bit lengthy. There is little like different contents, and you get only 6 questions. So this module is, I would say, you give a lot of effort to this particular module, and then you can be done with that portion. You don't have to worry about that because it is quite easy, as well as you get 4 questions from this particular module. So this is tool support for testing. Okay. So why do we need tools for testing? Why can't we do all the testing manually? What is the advantage of using tools?
It will be time consuming if we do
Time consuming,
things
right?
manually.
Sorry, but one thing is time, and the other one,
Prone to error.
right? Prone to error. Any
Efficient.
other? Efficiency, right? There are so many advantages, right? So this module deals with different tools for testing, and we will get to know different tools which we can make use of as part of the test process. So what exactly is a test tool? Any application which can assist you in any means in the testing process is called a test tool. So if you're using an Excel sheet for some kind of testing process, that can also be called as a testing tool. So whether we have been in software testing for some time, or if we just start our career, we know one thing for sure, that it is a tedious task and time consuming activity. So many times we will need to repeat the same time test for every build. So whenever a new functionality is implemented, or if there is a bug fix, we might have to repeat the same test. So it is a lot of repetitive activity. So there are many areas, not just the test execution part. There are many areas where you will have to do the testing again and again. So tools helps us to automate this task, and so we don't have to invest our time executing these steps again and again. For example, if you think that if you're executing 100 steps manually, how much time would it take? And what would be the time taken if the same 100 steps is being automated by using an automation script? So it takes much longer time to execute if we are doing it manually. So there is a lot of advantages of using the tools. So if you look into the syllabus, so they have given few different um, types of tools. So all these are one-liners. They have just given management tools, test management tools, testing, static testing tools. All these are one-liners. There is no uh, description for any of these tools. So what you need to do is you have to ask yourself few questions. What are the features that I expect from this particular tool? Who would be using it? When they will be using it? So you have to yourself ask these questions and try to answer that. That is the best way you would be able to remember the different tools, and you could also relate it to your work or project, so it will be very easy. Okay, so we'll start with the first one, management tools. So under the management tools, there are so many different categories, like the test management tools, like test rail, the requirements management tool. There is a defect management tool. So all these are different management tools. So what is defect management tool? What is defect management tool? What do you? So I have like previously said, three things you have to ask yourself: the features that you expect from that particular tool, who would be using it, when they will be using it. What are the features that you expect from a defect management tool? So any activity that you do during the defect life cycle should be managed by this particular defect management tool. So what are the different activities that you do during a defect life cycle? Storing information about the bug, like putting severity or priority. We should be able to attach a file or screenshot or a video recording, screen recording. So we should be able to change the status. We should be able to track who has made changes to that particular bug details. That is the audit trail. We should be able to provide the statistics, how many got fixed. So all these are different features that you expect from a defect management tool, right? So who would be using a defect management tool?
Tester.
Testers. So you can't specifically say testers. Testers are the one who would be mostly using. But being a bug, if it is a critical one, definitely all the people would be looking into it. So you can say testers mainly, the BAs, developers, managers, right? All of them would be using the defect management tool. So when they would be using, throughout the SDLC. So once the first sprint is done, we would start reporting the bugs, right? So we would be using throughout the SDLC. So now you know what is a defect management tool does. So can you tell what is the requirement management tools features? What are the different features of the requirements manage? So every time you can also think of one tool which you used in your project, so you can easily connect to it. So if you have used a defect management tool like Bugzilla or anything, you can connect to it. So it would be easy for you from an exam point of view. Okay. So what are the features of a requirements management tool that you expect from a requirements management tool? So when I ask you like who would be using, when they would be using, there was never a
Store
question.
information. Store information.
Yeah. Storing information. So storing different information. So for managing the different requirements, so you should be able to store the requirements or user stories. You should be able to check the consistency of the requirements. So for requirements, that is very important, right? It is not good that every time the requirements are getting changed. So we should be able to check the consistency. If someone is making any changes, we should be able to do a traceability between the requirements and test cases. We should be able to prioritize the requirements. We should be able to What else? Report the requirements to the corresponding developers or other team members. So all these are different features that you expect from a requirements management tool. So who would be using the requirements management tool? Mainly the BAs. So there have, when I say who and when, there have never been a question asked like who did this, who used this particular tool. That is not the way. So, but when you understand the concept, you will be able to answer the question. So, who would be using it? Mostly the BAs, but other team members also work from the requirement. So everyone will be looking into it. And the next one is test management tools. So, what are the expectations that you have from a test management tool? What are the expectations that you have from a test management tool? Again, so we'll just discuss now, but always when you revise, you try to ask this question yourself and try to answer. So we should be able to manage the different tests, like the number of tests planned, keeping a track of test data, number of tests failed. We should be able to log the test result. We should be able to prepare progress reports like quantitative analysis, like how many tests were run, how many passed, failed, defects fixed, outstanding. So we should be able to do a traceability of test cases, which is very important because as a QA, our main aim is that none of the requirements gets passed to the client without getting tested. So it is very important that we created some kind of traceability of the requirements. And so these are different features that we expect from a test management tool. So test management tool, we can say though this would be mostly used by the QA team members only, like the testers, test lead, test managers, and they would be using it mostly throughout the SDLC. So that is a management tool. So any tool which helps in increasing the test process efficiency by facilitating some kind of management like the requirements or test or defect and configuration. They are all management tools. And the next is static testing tools. So what is static testing? What is static testing?
Testing the documents without
Yeah.
executing the test case.
Yeah. So we have to be very clear when you read the question. So static testing is nothing. We are just reading the documents, or when you say reading, it is reading or reviewing. It is not just the documents. It could also be a code. Hmm? So when a senior developer reviews the unit test that is being written by a automation developer, that is also testing, static testing. So they are not actually uh, running the code, that is not dynamic testing. Rather, someone is reviewing your piece of code to check if there is any errors or issues. So that is also static testing. So static testing is you are reviewing something and giving the comment, so making corrections. So it is not dynamically execute, but you are reviewing the work. So one example is static analysis tools like Sonar Cube. So have anyone used Sonar Cube? So mostly um, like QAs won't be using it. It will be mostly automation QAs. They would be using the static analysis tools, or the developers who write the unit test cases. So what the static analysis tools does, so once you write the code, same like some senior or lead reviewing your static and reviewing your code, similar to that, a tool will be scanning through your code, whatever you have written, and then it will be finding out any vulnerabilities or errors in that particular piece of code. So that is static analysis. So static testing is reviewing or reading through the documents to see for any issues. Same like that for the code also. If you write a piece of code, the static analysis tools like SonarQube, what it can do, it can actually scan through the piece of code and identify any vulnerabilities or errors that is there in the that piece of code. So what are the features that we expect from a static analysis tool? It should be automatically able to scan and analyze the source code if there are any errors or vulnerabilities. It should help developers improve quality and reliability of their code. And then it should be able to communicate the comments to the relevant people. Then all these tracking, review comments, defects found, and reporting about these issues. All these are different features that we expect from a static analysis tool. So who would be using the static analysis tool? We can see the developers or the automation QA. So when they would be using the unit testing phase. So that is a static analysis tools. Next is test design and implementation tool. So test design tools and the model-based testing tools. So what is model-based testing tools? Model-based testing tools. So again, this is also for the developers or the automation testers. So sometimes when you have a very complex system design, or if you have say like 1,000 lines of code, it become very difficult to understand like which module is communicating with which other module. So in such cases, what they do is we use the model-based testing tool where the 1,000 lines of code would be converted into different models. So it helps to validate the models of the system, whether the system is right or not by generating test cases from the model. So here the behavior of the system is checked under predictions made by this particular model, or the what is the input given, what is the expected output. So from the specifications of the model, we would be able to like do a check on the system. So that is a model based system. Again, who would be using it? It will be the developers to identify any defects or inconsistencies in their model. So when they will be using it during the unit testing phase. And next is the test design tools. So what is test design tools? Test design. So it should be able to help us to design the test, to create the test cases, to create the test inputs. So they can even automate the process of generating test scenarios, helps to identify the possible combination of test execution. Sometimes you will be asked to like do the test for a particular OS and browser for its previous 10 versions. So it is very difficult for us to find out all the possible combinations. So if you use some design tools, we just have to input with the OS and browser, and it will give us all the possible combinations with the best coverage. So the test design tools will help us in designing the whole test, and to sometimes to create the test inputs. For example, if you want to do a performance testing for 1,000 users, is it possible that you can actually log in as 1,000 users and do the performance testing? No, right? So it's not possible. We can use 1,000 laptops or machines and log in and see how the system is performing. So in such cases, in order to do the performance testing also, we might have to create a design where for every template of that particular page, we might have to create a test input. So all these can be created using the test design tools. Next is test execution and coverage tools. So this is something which we are all very familiar with, right? So test execution tools like Selenium. So what are the features that you expect from a tool like Selenium? What are the features? Has anyone used Selenium or any other test execution tool? So there are different ways.
Running
Right.
test case.
Yeah. So we should be able to run the test cases.
Browser testing,
Browser testing.
cross-platform testing.
Right. We should be able to take the screenshot. We should be able to create reports. So there are a lot of things which we expect from an execution tool. Like So other than the tools which use a particular scripting language, there are also other ways like the capture and playback or record and playback option as well. So for small system, we can also take use of such tools as well. So it is more like a screen recording button. So once you click on the screen recording button, and then whatever actions you do on the screen will be recorded. So the next time when you want to actually run that particular test, you can actually go and play back the recording, right? So but it has limitations, so could only be used for small scale projects. So the one issue is that today you recorded while this button was here. The next day, when you next week or after 2 week, when you want to replay it, the UI might have changed and it will cause lots of errors. So that is always prone to error, the record and playback option. Whereas the scripting language gives you lots of flexibility. You can create your own test cases. You can do browser testing, cross browser testing, parameterization, parallel testing, and you can do different frameworks to make the process easy. So there are a lot of features that we expect from the test execution tools like Selenium. So next is a test coverage tool. So what is test coverage tool? Test coverage tool. So this is that tool which helps you answer this question, like how thoroughly have you tested? So when you get this question, don't think that it is a like the functional testing part alone. So when you say test coverage, there's a code coverage as well. So which part of the code is not yet tested? How thoroughly have you tested that? Question can be answered by this use of this particular test coverage tool. So measures of how much of the code or a functionality of a system is being tested by a particular set of tests. So it gives the percentage of code being covered by your test. And if you want to, like, if it is only 80%, it gives options to identify the extra test that could be added to exercise the missed coverage. So this will again be mostly used by the developers during their unit testing. So that is the test execution and coverage tools. Next is non-functional testing tool. So again, this one which we have discussed before, one typical example is the performance testing tool. So in order for you to do the performance testing, it is not actually possible manually. It is not possible we could log in as the 1,000 or 10,000 number of users. So we will have to depend upon a performance testing tool where it can actually simulate the those number of users. So that is a performance testing tool. So then there is also the monitoring tool. It is not necessarily a testing tool. So there are few tools which gives you the some suggestions like optimized usage, like the network usage, or what is a space left. So or they will be monitoring your system and giving you suggestions and optimization criteria. So that is not a critical testing tool. It just helps in the controlled testing. So that is a non-functional testing tools. Next is the DevOps tools. So what is DevOps? Yesterday we have covered DevOps. So development and operations together, we call it as a DevOps. In DevOps, we integrate a lot of CI/CD tools. So if you have integrated automation using Selenium in your CI/CD pipeline, that is also a DevOps tool. So any tool that is being integrated in the DevOps pipeline to help the process of DevOps, those are all DevOps tools. So any CI/CD tools like Git or Jenkins or Selenium or SonarQube or whatever helps in the process of DevOps, these are all um, DevOps tools. So which supports the DevOps delivery pipeline, the workflow tracking, automated build process, all these are DevOps tools. So there is also some configuration management tool. Again, this is also not a critical testing tool, like configuration management tools which will keep the information of the build version, keeps the tracks of different configuration like the OS or backend for different software versions, how many builds are done, so how many releases are made, who checked in, who checked out, the access control, who updated, who made changes, what changes were made. That is the audit trail. So all these different configuration related features that is being provided by the configuration management tool. So that also comes under the DevOps tool. And finally, we have the collaboration tool. So when you want to communicate with different teams, you might be just not be working together with the internal team. You might have to work with different external teams as well. So there should be different collaboration tools which should be there in place inside the inside your own organization, and to communicate with the other team members which are outside the organization also. So any tool which helps you in collaborating with different teams, or which facilitates communication between different teams, those are all the collaboration tools. So there is Slack, Microsoft Teams, Jira, Confluence, etc. And finally, we have tools supporting scalability and deployment standardization. So there are containerization tools like Docker and Kubernetes. So which will help you actually in, for example, if there is a company runs an e-commerce platform that experience very high traffic during a holiday sale. So there is a holiday sale going on and there is a very high traffic. So what they can use the virtual machine. So what do you mean by virtual machines? Which is a software implementations of the physical computer. So they can actually make use of the VMs to handle this increased load. So by provisioning additional VMs to distribute this traffic, they can ensure that their website remains positive. So that is one way of like supporting the deployment. And then there is a different deployment and containerization platforms like the Docker, Kubernetes, etc. So Docker is a popular containerization tool. So where they ensure that each service has all the necessary dependencies and configuration to run correctly. So all these dependencies would be packed into a single lightweight executable unit, which is called the containerization. In short, it should be helping to support scalability. In case if you want to scale out your software, those tools which help you in supporting the scalability and deployment standards, we call it as a like tool supported for scalability. So few examples are the Docker, Kubernetes, etc. So these are the different tools which is mentioned in our syllabus. And other than that, any other tool that assists you in testing, as we have discussed initially, even if it is an Excel sheet which helps you in some kind of testing process, to ease some kind of testing process, that can also be considered as a testing tool. So these are the different tools supporting the testing. And next we have benefits of using tools to support test execution. So there are different benefits of using tools in supporting test execution. Let's see which are the different benefits. So the first one is always reduce the repetitive manual work and the saving times. As we have discussed initially, we might have to do the same test again and again, whether it is regression or retesting. We might have to repeat the same test again and again multiple times. So by using tools, we can reduce the repetitive manual work and save a lot of time. That is one thing. And then there is greater consistency and repeatability. So we might make small changes every time we execute a test case manually. Say, for example, you are testing a login of a particular application. So every time you do the login test, you might make small changes. Say, for example, you can log into the same account using your Gmail credentials or using any social platform accounts, right? So there is different way by which you can execute the same test case. So there is no consistency. So the first time you did with login credentials, next time you did the test using social media account, next time you used some other way to test the same test case. So there is no consistency. So first time you did a test with some way and next time you did some other way, and you find out an issue and you actually don't actually realize that I was doing it in a different way. So when you report the bug, you might mark it on the first way. So even if you run a test case 10 times, you can make small minor changes that even you don't realize. But if it is a case of a testing tool, you write 10 steps and you run it for 1,000 times, it is not going to change. It will be doing the same exact 10 steps unless we go and make any changes. So consistency and repeatability is very high if you use a tool. Whereas if you do it manually, the consistency is very less. And then there is easier access to information about testing. So it is so you have 500 test cases done. You have 500 test cases. 400 is executed and 50 are pending and 50 is like blocked. So you are telling this to your senior manager or your team members by using an Excel sheet. How they will interpret or how they will have insights from that particular information. But if you were representing it using a pie chart or something, they will easily get an information. Okay, majority of the cases are done, only few are left, only 50 100 is left to be completed. So there is an easier access to information about not just about testing, any process that is involved, if it is presented using a tool or visually represented. That is one other advantage of the or benefit of using the tools. So next is more objective assessment. So test automation provides a more objective and consistent evaluation of software's performance and quality compared to manual testing. So automated tests run the same way every time, as we have discussed about the consistency, eliminating any human error or variability. Human objective assessment is very less. Whereas one significant area where this objectivity is crucial is measuring the test coverage. So test coverage, it is very difficult for humans to actually come up with an answer to the question, like how thoroughly we have tested, how much of the code is being covered. Whereas we can always look up for a testing tool without a without a confusion that it will give a proper result for the coverage. So that is, imagine if you have a large web application with hundreds of features and thousands of lines of code. So to ensure that all parts of the code are tested, it is essential to track test coverage, which refers to the percentage of code exercised by the test. So these are the different benefits. So few more benefits we have: reduced test execution time to provide earlier defect detection, faster feedback, and faster time to market. So like if you take 1 hour to do a manual test execution, then you can only report the bugs after that 1 hour. And so the bug fixing will get delayed. And so the whole process is getting delayed to take it to the market. Whereas if you're using a testing tool, execution time is very less. So the defect could be detected very earlier and there is a faster feedback and issues could be fixed earlier and the faster time to the market could be achieved. And above all this, because of the time saved for with all the use of this automation test, testers get time to design new, deeper and more effective tests for complex tests where more critical thinking is needed. So testers can actually spend more time in designing such test cases where deep and more critical thinking is needed. So these are the different benefits of using testing tools. So, and next is risk. So it is not just that we'll always have some benefits alone. There could be risks as well. So the first one is expectations for the tool may be unrealistic, including the functionality and ease of use. So all of the different organizations are using this particular tool, Selenium. And if we also have a huge project, but we haven't used any testing tools. So if we just go and acquire this particular Selenium tools license version or something, that is going to solve all our problems. So keeping such unrealistic expectations is very risky, because this particular tool might not be of use to our functionality for that particular application. So our this particular application is running on one platform, and this tool is not compatible to that platform, then that is of no use. And it is not like every tool is very easy to use. There will be a lot of technicalities which we need to know to actually make use of a testing tool. So keeping the expectation realistic is very important, and having to learn about the tool in detail to understand the working and features that of that particular tool is very important to reduce the risk. So keeping unrealistic expectations is a risky factor for any kind of testing tools. And the next one is inaccurate estimation of time, cost, effort required to introduce a tool, maintain test scripts, and change the existing manual test process. This could also be a little risky if you are not keeping enough effort. Like when you plan to move to a different tool, you have to actually do a proper estimation of the time to actually take advantage of that particular tool, the cost. If it is a very small project, like a supermarket admin project, you might not actually have to go for a license version. So you have to think about the purpose, and then look at the price, and then we'll have to decide whether we should actually go for that particular tool or not. So inaccurate estimation of time, cost, the effort, that is very important. So if you don't have enough resources in your organization who can actually work on that particular tool, so there should be proper effort or training that is to be given to the uh, team members to actually use the tool. So inaccurate estimation of time. You bought a highly paid license version to your organization, but no one knows how to use it. So that will be risky. So before we actually acquire a tool, we have to do a proper estimation of time, cost, effort, and to maintain the test scripts. And if you were following a manual test process, that change, how this change could be acquired. So all these things should be properly estimated. Otherwise, it will be going to be a huge risk. And using a testing tool when manual testing is more appropriate. Say we'll take the same example, the supermarket admin application. So you might not need a any tool to actually do the testing. So you could easily and accurately do the same thing with the manual testing. So you might not actually have to go for any kind of tool. So tool should be decided based on the project and process characteristics. So if you try to use a tool where manual testing more appropriate, that will also be risky. And relying on tool too much. Example, ignoring the need of human critical thinking, which is very important. So if you have a new automation tool or a test coverage tool, so we have to understand one main thing. So every test case that is being written using a test script or any scripting languages, proper thinking, human critical thinking should be involved in the first time while he is writing the test cases, right? So proper human critical thinking is needed for any tool to actually use it properly. So you have written 10 test cases. You actually missed on one of the test cases because you were relying on too much on the tool. You thought like that all of the things were covered actually. So if you rely on a tool too much and ignore, there is no necessity for a human critical thinking, that is a very big issue that could result in critical issues and risk. So these are few risks associated with tools, and the next is dependency on the tool vendor, which may go out of business. So any product that we buy from the market, not just for the software, we always go and check for the review or the feedback how this particular vendor is, right? So dependency on that particular tool vendor, we should have a proper check on what is a review or how this tool has been used. So if the tool will get retired, or how they respond to the queries, if there is any upgrades, where do they do proper defect fixes, that is very important. So from a vendor point of view, how well we will have to depend on the tool vendor. So you have a huge project, you bought this particular tool, but at some point, this is a 3-year long project, and after 1 year, they plan to retire the tool. That will be a risk for the whole project. So we should have a proper study on the tool vendor before we actually plan to acquire the tool. And using an open source software which may be abandoned, meaning that no further updates are available, or its internal components may require quite frequent updates as a further development. Again, this is also complements with the previous point. So if you're using an open source, even if you are not going for a paid version, even if you're using an open source software, make sure you are using it for only for a small scale project. If you are, again, for the same kind, if you're using it for a critical project which might be running for 4 to 5 years, and at some point, if the open source software is being abandoned, that will be a huge risk. So we have to make sure what is the requirement for our project, how this particular open source software can be maintained throughout the project duration. It is very important. The automation tool is not compatible with the development platform. So this one we have already discussed. If the requirement or this particular application is running on a particular platform or technology, and this automation tool is not compatible in that, there is no point in acquiring that. That is a risky thing. Choosing an unsuitable tool that did not comply with the regulatory requirements or safety standards, which is again important. So yesterday we have discussed about the regulatory acceptance testing, right? So for any application, based on that domain, it should be complied to some regulatory standards. So if you are using a tool which is not complying with the regulatory requirements or safety standards, that is a very huge risk. So these are the different risks associated with the using of tools. So this is very simple module. Only few contents are there, and there are 4 questions being asked from the module as well. So is there any doubt from module 2 or module 6? You can ask now. Any doubts? You can also go through the syllabus and notes which is being given to you. And if you have any doubts regarding module 2 and module 6, you can communicate in your channel which is given to you for communication, and they will take those questions to us. So if there are no questions, we will move to the questions from module 2 and module 6. So you can answer the questions on the chat. Put the options on the chat. Let me try to share the questions. Are you able to see the screen?
Yes, ma'am.
Okay. So the first we will have questions from module 2. Which of the following statements best describes the acceptance test-driven development, ATDD approach? In ATDD, acceptance criteria are typically created based on the given when then format. B. In ATDD, test cases are mainly created at component testing and are code-oriented. C. In ATDD, tests are created based on acceptance criteria to drive the development of the related software. And option D, in ATDD, tests are based on the desired behavior of the software, which makes it easier for team members to understand them. Which is the correct option? Option C. Any other answers? So it is a like the definition of ATD asset. So here the test cases are created based on the acceptance criteria, and those will be driving the development of the software. Okay. So we'll move to the next question. Which of the arguments below would you use to convince your manager to organize retrospectives at the end of each release cycle? A, retrospectives are very popular these days and clients would appreciate it if we added them to our processes. B, organizing retrospectives will save the organization money because without them, end user representatives do not provide immediate feedback about the product. C, process weaknesses identified during the retrospective can be analyzed and serve as a to-do list for the organization's continuous process improvement program. And finally, D, retrospectives embrace 5 values, including courage and respect, which are crucial to maintain continuous improvement in the organization. You have to select one option. Option C. Yeah. So the first option says retrospectives are very popular these days and clients would appreciate it if we added them to a processor. Okay. So it is not about popularity and the clients would not be a part of the retrospective. All the team members would be the part of the retrospective. Next is organizing retrospective will save the organization money. That would in no way save organization money. And the third one is process weakness. So why we are conducting retrospective, we want to improve from where we were in the last meeting or where we were in the last iteration or where we were in the last sprint. So we are trying to improve ourselves. So the process weaknesses would be identified and analyzed. So the correct option here is option C. Next is which types of failures fit with which test level. So they have given 4 different types of failures and 4 different types of test levels. You have to identify which failure belong to which test level. No answers. Option D. Is there any other options that you have got other than option D? So option D is the correct answer. So here, the first one is failure in the system behavior as it deviates from the user's business need. So it directly says it's a system behavior. So that will be system testing. So 1 to C. So there is only one option with one being like matched to C. So D is the correct answer. But some cases you might get confused with different options. So you might be very sure about 2 options and you are not very sure about the other 2 options. So in such cases, you can go to the options and match with the correct options which you have and come to the final answer. So the second option is failure in communication between components. So components and the communication, that is a component integration testing. So 2 should be to B. And next is failure in logic in a module. So logic code program, that means it is component testing or unit testing. That is 3 to A. And finally, failure in not correctly implemented business rules, that is a acceptance testing. So the correct option here is option D. Next is, which of the following statements about the chosen software development lifecycle is correct? If agile software development is used, system test automation replaces the need for regression testing. If a sequential development model is used, then the dynamic testing is typically restricted to later in the life cycle. If an iterative development model is used, then component testing is typically performed manually by developers. And finally, if an incremental development model is used, then static testing is done in early increments and dynamic testing is done in later increments. Select one option. Option B. Any other answers? Okay. So the first option says if agile software development is used, system test automation replaces the need for regression testing. So in agile, we don't replace anything with any other testing, right? So if system test automation cannot be replaced by regression testing. So system automation should be test automation should be done in the system testing phase only. If a sequential development model is used, then the dynamic testing is typically restricted to later in the life cycle, which is true. So in waterfall model or V model, we know that only when the previous phase is completed, the new phase will be started. The next phase will be started, right? So if you want to do a dynamic testing, that could only happen towards the end of the life cycle, to only later in the life cycle. So this is the correct answer. And what is the option 3? If an iterative, so you are confused with option D. Yeah. So this is the correct answer. So the third option says if an iterative development model is used, then component testing is typically performed manually by developers, which is wrong. So component testing will be done by developers. They might use some tools. Mostly they will use some tools. So if an incremental development model is used, then static testing is done early in the increments and dynamic testing in later increments, which is wrong, right? Because in incremental model, what happens? It will the whole application would be divided into different increments, and in every increment, all the different phases happen. So in the same increment itself, both static testing as well as dynamic testing will happen. So that is wrong. So here the correct option is option B. Next is which of the following is correct regarding functional test. So they have given few options, and like you have to find out which is true and false regarding functional testing. So which of the following is correct regarding functional testing? First one involves tests that evaluate functions that the system should perform. Second, should be performed at all test levels. Third, considers the behavior of the software, so black box techniques may be used to derive test conditions and test cases. Four, derives tests based on the system's internal structure or implementation. And finally, we have evaluates characteristics of the systems and software, which is true, which is false regarding functional test. Any other options? We have got B. How can B be the answer? Because this uh, B says option 4 is correct, right? But option 4 says derives tests based on the system's internal structure. So in functional testing, are we worried about the system's internal structure? No, we are just looking at the functionality. So that is wrong. So in such questions, you can always like evaluate the options. So the as I have mentioned before, you can go through the options. You can take the options which you are sure, very sure that it is wrong or very sure that it is correct. You can pick that option and from there go to the option and find out the correct answer. That can also be done if you're not very sure about all the options. So here the correct option is option D. So option D, so the first one is it involves tests that evaluates functions that the system should perform. That is the direct definition of the functionality test. And next is should be performed at all test levels. So this one which we have discussed before, like it could be done for component integration as well as system integration or any different levels of testing as well. So 1 and 2 are correct. Third is considers the behavior of the software. So black box techniques may be used. So you are not looking into the internal structure, you are looking into the specification based or how the functionality of the system is working. So black box techniques are used. So 1, 2, 3 are correct. And the fourth one says test based on the system's internal structure, which is wrong. We are not looking into internal structure. So 1, 2, 3 are correct, 4 is false. And the final one evaluates characteristics of system and software. This could be little confusing. You might feel like whether it is functional characteristics or non-functional characteristics. But then we have here 1, 2, 3 is correct and 4. So there is only one option which matches to that. That is a option D. So here the correct option is option D. Next is which of the following statements are true? For every development activity, there is a corresponding testing activity. Each test level has the same test objectives. The analysis and design of tests for a given test level should begin after the corresponding test development activity. And finally, testers should be involved in reviewing documents as soon as the drafts are available in the development cycle. So, which of the following statements are true? Option D, 1 and 4. Yeah. So the first one says for every development activity, there should be a corresponding testing activity, which is true. And the second one, each test level has the same test objective, which is wrong because each test level has its own unique test objective. For component testing, it is to identify the issues in the code. Whereas for system, acceptance testing or system testing, we are checking if it actually fits the purpose, if it can actually do all the specifications mentioned in the requirement. So the test objective is specific and unique to each test level. Next is analysis and design of tests for a given test level should begin after. It is not after. It should happen during the corresponding development activity itself. So 2 and 3 are wrong. And finally, we have testers should be involved in reviewing documents as soon as the drafts are available in the development cycle. So 1 and 4 are correct. So here the correct option is option D. So the next question is which of the following is a good testing practice that applies to all software development lifecycle? Testers should review work products as part of the next development phase. Testers should review work products as soon as the drafts are available. Testers should review work products before test analysis and design begins. Testers should review work products immediately after they are published. Option D. Any other answers other than option D? So this was one thing which we discussed, like testers should review work products as soon as the drafts are available. Say they should not be waiting for it to get published. They should not be waiting for the final streamlined or baseline document to get published. As soon as the first draft is available, so we know that draft is something which is not complete, which is not ready for getting published. So as soon as the first version of the document is available, we should be involved in reviewing the work product. So the correct option is option B. So sometimes you might get confused, like which of the following is a good testing practice that applies to all the SDLC. So then you might think like, okay, this is not applicable for like waterfall method because they are not doing a testing team is in getting involved only towards the later. So all these good testing practices are irrespective of the STLC. So you just have to look into the concept of the good testing practices and understand that irrespective of the STLC, it should be there for all the different STLC. So testers should review work products as soon as the drafts are available. They should not be even waiting for the final document to get published to get involved or to get involved in reviewing the work product. So here the correct option is option B. Next is, which of the following is an example of a test first approach to development? Test driven development, coverage driven development, quality driven development, and feature driven development. So this is a straightforward question. Option A is the correct answer. That is a test driven development. Next is, which of the following is most likely to be performed as part of system testing? So we have few different levels of testing. So which of these will be performed as part of system testing? Security testing of a credit management system by an independent test team. Testing the interface of a currency exchange system with an external banking system. Beta testing of a remote learning system by courseware developers, and finally testing interactions between the user interface and database of a human resource system. So which of the following would be most likely to be performed as part of system testing? A. Security testing of a credit management system. Any other answers? A. Any other answers? Yeah, so the correct answer here is option A. So we'll go through the other options. So the option B says testing the interface of a currency exchange system with an external banking system. That is two different systems that is being integrated, and so it is system integrated testing. Next is beta testing. So that is definitely acceptance testing. And finally, testing interactions between the UI and DB of a human resource system. So for the same system, different components are being integrated and is verified. That is component integration testing. So the only option is security testing of a credit management system. So it is a system being tested as a whole by an independent test team. So here the correct option is option A. Next is the navigation system software has been updated due to its suggesting routes that break traffic loads, such as driving the wrong way down one-way streets. Which of the following best describes the testing that will be performed? So there has been an update on the navigation system software. Why there is an update? Because it has been suggesting wrong way in a one-way street. So which will be the best describe this testing that will be performed? A, B. So it is B. It is actually B. So we have to make sure that the bug is fixed. So we will do a confirmation testing and then do a regression testing to make sure there are no issues created. So there will be confirmation testing and then the regression testing. So that is it regarding the module 2. And we will move to few questions from module 6 as well. So the first question is, which item correctly identifies a potential risk of performing test automation? It may introduce unknown regressions in production. Sufficient efforts to maintain test wear may not be properly allocated. Testing tools and associated testware may not be sufficiently relied upon. It may reduce the time allocated for manual testing. So, which of these could be a potential risk? C. Any other answers? B. So the correct answer here is B. So one thing about ISTQB is the questions could be confusing. So we have to read the question very properly more than once to actually understand before we actually jump into the answers. Because here it says correctly identifies a potential risk. Hmm? So this option C says testing tools and associated testware may not be sufficiently relied upon. That is not a risk. So if you are acquiring a tool, we are acquiring it to actually rely upon it. So it is not a risk. But if you are not maintaining or estimating proper efforts to maintain the software testware, then that is going to be a risk. So here the correct option is option B. So the other options are it may reduce the time allocated for manual testing. Again, that is not a risk. And it may introduce unknown regressions in production. So just acquiring a new tool does not create any regression for our test. So next is which of the following is most likely to be a benefit of test automation? So again, there are questions which has this most likely term. So that such questions should be answered very cautiously because there could be answers, more than one answer which would be correct. So you have to pick that one answer that is more correct. There could be answer. So you pick one answer, you feel like that is a correct answer. There could be one answer which is more accurate than your answer. So um, such questions which has a most likely term should be read properly before answering the question. Which of the following is most likely to be a benefit of test automation? It provides coverage measures that are too complicated for humans to derive. It shares responsibility of the testing with the tool vendor. It removes the need for critical thinking when analyzing test results. It generates test cases from analysis of the program code. A. So here the correct answer is option A. It does not share. So some the coverage measures we will always have to depend upon a automation tool if it is very complicated to actually do a proper coverage. The other options are it shares responsibility of testing with tool vendor. That doesn't happen anytime. It removes need for critical thinking. Again, that is wrong. Whatever test is to be created, even with the tool, proper human critical thinking is needed. And for analyzing the results as well, we need proper critical thinking. It generates test cases from an analysis of the program code. That also doesn't happen. So here the correct option is option A. Next question is, okay, so again, okay, so that is a repeated question. Next is, which of the following is most likely to cause failure in the implementation of a test tool? Failure in the implementation of a test tool. A. Underestimating the demand for a tool. B. Purchase price of the tool. C. No agreed requirements for the tool. D. The cost of resources to implement and maintain the tool. So all these options might feel like these could all be a cause for failure. So you have to find that one option which is the most likely cause of failure. So without which there is no point in implementing that particular test tool. So which is the correct option here? Option A. Other than option A, is there any other options? C. C. So here the correct option is option C. So underestimating the demand for a tool. As I said, that could also be a reason for failure. Only if option C was not there. First, our purpose of testing or use of any testing tool starts from a list of agreed requirements. So if there are no agreed requirements for the tool, there is no point in acquiring the tool itself. So this could all be a reason for failure, but among these, C is a more correct answer. So if there are no agreed requirements, any usage of tool starts from some list of agreed requirements. If there are no agreed requirements, there is no point in acquiring a new tool. So here is the correct option is option C. And the next final question is, what benefits do static analysis tools have over test execution tools? A. Static analysis tools find defects earlier in the life cycle. B. Static analysis tools can be used before code is written. C. Static analysis tools test that the delivered code meets business requirements. And finally, option D. Static analysis tools are particularly effective for regression testing. This is the correct answer. Option D. Option B. Option A. So here the correct answer is option A. Because static analysis tools find defects earlier in the life cycle, because even before actually executing the code, the analysis tools can identify if there is any vulnerabilities or compatibility issues. So they will scan the code and identify the issues. So the static analysis tools find defects earlier in the life cycle. That is the correct answer. Option B, static analysis tools can be used before the code is written, which is wrong. We are actually scanning the code to find out any errors or issues. And option C, static analysis tools test that the delivered code meets business requirements. So it is being tested before the code is being run dynamically. So option C is also wrong. And option D, static analysis tools are particularly effective for regression testing. How is that effective for regression testing? So in regression testing, we will be running a test suite with the priority test cases, which has already been tested right before. But static analysis tools, what they do is whenever there is a code, it can actually scan the new piece of code to check for any errors or vulnerabilities. So option D is also wrong. Here the correct option is option A. Static analysis tools find defects earlier in the life cycle. Okay, so with that, we have come to the end of this session. So if you have any questions regarding module 2 or module 6, you can ask now. Also, you can go through the notes and PPGs which is being provided to you. Also, you can go through all the possible like sample questions which is available from the team as well as from the external resources. So that would be one important thing you have to do to easily like pass the exam, because sample questions are very important. And regarding the module 2 and module 6, as I have discussed before, like module 6 has only 1.5 page content. So make sure you first study this module 6 and keep it aside, because there, if you do that well, then you can make sure that you have scored 4 marks already. So yeah, and for module 6, you have a little bit of content. You can go through it multiple times and do a maximum number of sample questions. Okay, so if you have any questions, you can ask now, or else you can leave. Thank you. Prepare well for the exams. All the very best. Thank you.
Can you suggest one site where we can find this mock test book?
There are a lot of dumb questions available, ISTQB dumps. And then Quizlet is one site which is very good, Quizlet. Yeah, those are the sites. Also, you can refer to the sample questions which is available from the ISTQB website because I don't think many of the websites will have the latest version sample questions. So ISTQB is one website where you can find around three sample question paper set. So only since May you have this version 4. So many websites might not be having, but Quizlet, I guess they have good number of questions.